Chapter 12 has two parts to it, solids and liquids, and then the third part is phase diagrams. So 12.1, liquids. Be aware that liquids are the least common state of matter in the universe, compared to solids, gases, and even plasma. Even though there are large bodies of liquids that you know of, and it seems like liquids are all around us, they are the least common state of matter. Think about the periodic table. At room temperature, there are only two liquids. The main reason, or the main fact as to why liquids only exist sporadically is because they exist within a narrow temperature and pressure range. Liquids are considered to be fluid, and remember that a fluid is a substance that can flow, and because of that, it can take the shape of the container it is held in. Some properties of liquids: they have a definite volume. So a liter is a liter, no matter what container you pour it in. They have an indefinite shape because they do take the shape of their container since they are fluid. So if you have a pop bottle full of liquid and you pour it into a fishbowl, it will now take the shape of the fishbowl, but the volume will still be the same. So definite volume, indefinite shape. If you recall back to our gases chapter, we said that gases have very low density. Liquids have a very high density, and it is because their particles are close together and there are strong attractive forces. Liquids are incompressible. The particles are pretty close together, so it's very hard to force the particles even closer together. And liquids have a slow diffusion rate. The way to increase their diffusion rate is to increase temperature. Surface tension is another main property of liquids. Surface tension is defined as a strong force of attraction that pulls adjacent liquid molecules together. And it basically causes a dome-like shape to form at the very surface of the liquid, because if you look at the picture, you can see that all of the particles are being attracted to each other. There's nothing pulling the surface of the liquid's particles upwards. They're all pulled downwards, and that creates a dome-like shape. This is a little severe of a dome-like shape, but you can see even in a glass of water, if you fill it up to the very top, it will create that dome-like shape. And the higher the attractive forces, the higher the surface tension is going to be. So water actually has the highest surface tension out of our most common liquids. This is why something can float in water and not break apart. Like a leaf floating on the water doesn't break the particles of liquid apart and it sinks. A bug can sit on the surface of water. It has to do with the way that those particles are connected, the strength of them. Hydrogen bonds, although they're weak, there's lots of them in water. So that kind of creates this nice connection between molecules. Capillary action is another trait of liquids. Capillary action is when the surface of a liquid is attracted to the surface of a solid. Basically what happens is the liquid molecules are pulled upwards along the surface of the solid against the pull of gravity. So some examples: chromatography. You may have done this in elementary school or in forensics class. You have a liquid that moves up the paper away from the pull of gravity. Plants. This is how plants get water from their roots to their leaves. Transpiration is what it's called. So maybe you did this in elementary school where you put a piece of celery, a celery stalk, in liquid that was colored, and eventually the leaves of the celery got colored. You can also do this with white carnations, and that's because the liquid moves up the solid surface against the pull of gravity and is absorbed. This is also why a meniscus of a graduated cylinder forms. So we always tell you in science class, you need to look at the bottom of the meniscus. Okay? This raised portion is simply because of capillary action. the sides of the liquid are pulled up and attracted to the sides of the solid. So you get that inverted dome shape. That's why you need to read the bottom for proper volume measurements. Part 2 of this section is types of liquids. There are two main types. Volatile liquids are ones that evaporate quickly due to their weak attractive molecules, weak attraction between molecules. These are usually easy to smell as well because the smell comes from the evaporation of the liquid into a vapor that we can smell. Little energy is required to break these bonds, so just general room temperature heat can cause that trigger from liquid to a gas, change of state. So as I said, most of these have a smell that you can quickly smell after opening them because they start to evaporate and turn to a gas, and that is how you smell it. So anything like rubbing alcohol, gasoline, ammonia, perfumes, things like that are considered volatile liquids. Easily evaporate, little energy to break the bonds, low attraction between molecules. On the flip side, we have non-volatile liquids. It's just the opposite. So these are going to be liquids that evaporate slowly because there are strong attractive forces between the molecules, and a lot of energy is required to break those bonds for a change of state to occur. So the best examples of this are oil and water. So if you swiped oil and water on the sidewalk, and then beside that you swiped rubbing alcohol, the rubbing alcohol would disappear, it would evaporate very quickly. The oil and the water are going to sit a lot longer because they have very strong attraction between molecules, and they're not going to change state very easily. Eventually water evaporates, but it takes a lot longer than volatile liquids. So we've talked about water a lot already. It's our most common liquid for humans, and it's a unique liquid. So properties of water at room temperature in its liquid form. It is colorless and odorless, transparent, you can see straight through it, it's not opaque. It has no taste. Sometimes we think water has taste, that's because of minerals that have been added to it. Or perhaps it's been purified if it had minerals in it. Water is the only liquid that becomes less dense as it freezes. So think about an ice cube. An ice cube floats in liquid water. So frozen water floats in liquid water. Usually frozen things sink because they become heavier. Well, water actually expands as it freezes instead of contracts. So what happens is you have this lattice that forms. So you have the red oxygen and the white hydrogens, like this picture up here. So all of these are molecules of water. And what happens is these hydrogen bonds that hold them together form a lattice, and there's air pockets in between. So air gets trapped in between, and that actually helps water to become less dense as a solid than a liquid, which is why it floats. That is the only reason. So think about how important this is to nature. Okay, many aquatic animals can live in the water still even when it's frozen on top. If not, the ice would sink and crush them or harm their environment or change their environment. Because the ice floats, the aquatic animals can still live in their normal environment and just have this layer on top. And usually, if they need to come out of the water, they'll just make holes so they can escape. But fish, if you have a pond, they're perfectly fine under the water because the temperature actually stays insulated for their needs, and they can still swim and get the oxygen they need from the water. So like I said, section 1 was about liquids, and you need to know the main important properties of liquids and also the uniqueness of our liquid water.